Electronics in hybrid electric vehicles. Introduction. Power electronics is one of the enabling technologies propelling the shift from conventional gasoline or diesel engine powered vehicles to electric, hybrid, and fuel cell vehicles. This video discusses power electronics used in hybrid electrical vehicles. This slide shows the configuration of typical series hybrid electrical vehicle powertrain. In this configuration, the internal combustion engine ICE drives a three-phase permanent magnet synchronous generator whose output is a three-phase voltage with variable frequency and variable voltage. This output needs to be rectified to a direct current DC voltage. The front wheels are driven by an induction motor which needs to be controlled by a voltage source inverter VSI or a current source inverter CSI. An energy storage system is connected to the DC bus between the generator or rectifier output and the inverter. However, there is a bidirectional DC to DC converter that manages the charge or discharge of the battery as well as controlling the DC bus voltage. In conventional vehicles, the air conditioning compressor is driven by the engine through the belt. In advanced hybrid electrical vehicles, the engine is turned off very often during stop and go driving patterns. In order to have air conditioning compressor while the engine is off, the air conditioning compressor needs to be driven by an electric motor which runs from the hybrid battery. There may be an electrically driven hydraulic pressure pump for the vehicle's hydraulic system such as fractional brakes, power steering and so on. The air conditioning motor and the compressor motor are typically brushless DC motors with an inverter. In addition, auxiliary components such as headlights, wipers, entertainment systems, heat seats and so on run from the 14-volt auxiliary battery. Most advanced hybrid vehicles no longer have an alternator, which means the 14 volts battery needs to be charged from the high voltage battery. On the other hand, even if an alternator is present, when the engine is off, the 14 volts battery can still be drained quickly without proper charge maintenance. Therefore, it is necessary to have a DC to DC converter to charge the 14 volts battery from the hybrid battery. Even though there are commonalized between the power converters used in hybrid electrical vehicles and one is used in other industrial, commercial or residential applications, there are some unique features specific to automotive applications. Examples include wider ambient operating temperatures -20 degrees centigrade to 50 degrees centigrade, vibration and shock, electromagnetic compatibility and thermal management. This slide shows the integrated main power electronics unit used in control the circuits. The power electronics units consist of the bidirectional DC to DC converter that links the hybrid battery and the DC bus. There are motor drive circuits that control the front and rear motor or generators. The issues to be addressed in the design of hybrid electric vehicles, power electronic circuits. Now coming to the first one is the electrical design. This design includes the main switching circuit design, controller circuitry design, switching frequency optimization and loss calculations. Second one, control algorithm design. This includes developing the control algorithm to achieve the desired voltage, current and frequency at the output and to realize bidirectional power flow as needed. Third one, magnetic design. This includes the design of inductors, transformers and other components such as capacitors needed for filtering, switching and the gate drivers unit. Fourth one, EMC design. This includes understanding the electromagnetic interface issues, analyzing switching transients and circuit layout that minimize the parametric inductance and capacitances. Fifth one, mechanical and thermal design. This includes modeling of the loss of power devices and magnetic components, cooling system, heat sink and enclosure design and integration of the power electronics units. Principle of power electronics. In broad terms, power electronics is a discipline that studies power converters which process and control power flow using electronic means. It mainly involves the use and control of power semiconductor switches such as power diodes, insulated gate bipolar transistors IGBTs and metal oxide field effect transistors MOSFETs. And this slide shows a typical power converter will consist of 4 segments: switching and peripheral circuits, filtering circuits, control circuits and feedback, and an optional user interface. Types of the power converters. Power converters are generally classified by their input and output. Since the input and output of a power converter can be either alternate current AC or direct current DC, there can be 4 types of power converters. First one, DC to DC converter, DC to AC inverter, AC to DC rectifier, AC to AC cycloconverter. The first 3 types of power converters are well used in hybrid electric vehicles. The fourth type, AC to AC cycloconverters, is only used in high power AC to AC systems to control the voltage magnitude and frequency of large motors. However, AC to AC conversion involving an AC DC circuit and a DC AC circuit is not unusual. Depending on the powertrain configuration and level of hybridization, a hybrid electrical vehicles can involve one or more power converters of different types. Coming to the main circuit, switches, peripherals. The main circuit consists of power semiconductor devices, switches and diodes, and peripheral circuits. The semiconductor switches are controlled to run on and turn off at a frequency ranging from a few kilohertz to few 10 of kilohertz for hybrid electrical vehicle applications. Depending on the voltage level of the systems, both MOSFETs and IGBTs are used in hybrid electric vehicle power converters. Coming to the filtering circuit, the power electronics converters generally involves LC low pass filters that will filter out the high frequency components of the output voltage and let the low frequency components or DC components pass to the load side. Coming to the control and feedback circuit, control and feedback typically involves the use of microcontrollers and sensors. Hybrid electric vehicles powertrain applications generally involve feedback torque control. Current feedback is generally necessary. Thank you.